It's got some great features, the magnesium oxychloride cement itself, depending on how it's made, carbon neutral. There's a product called Novachem, developed at Imperial College in England, which won global awards as a carbon sequestration material. More recently, there was an article about a Dr. Michael Hitch at UBC who was doing research with magnesium silicate, which is found in all of the mine tailings in BC. He found a way to mill the molecules or the ore in the tailings so that it increased the surface area. It causes it to uptake atmospheric carbon dioxide, forming magnesium carbonate, and Michael's idea was to use that as a carbon sequestration. To get a new cement material accepted into the North American Building Code, though, would be a long, arduous process, and so we came to him with our product, which has already got basic market acceptance. So we have a relationship now with UBC that we are going to use to properly quantify the carbon footprint of our product. It's a very important motivator for me. It bonds with a variety of fillers, not just cellulose. So one of the things that we are starting to work with is FP Innovation's new nano cellulose fibers. That could be another way that we can increase the properties of the board. The ingredients, as you see, are safe and healthy. They're suitable for people with hypersensitivity to chemicals. There is no outgassing. There's no formaldehydes, things that you find. There's no silica. There's no carcinogen. So comparing with the fiber cement or the gypsum, this product is very safe, healthy, and benign for people to use. And unaffected by most industrial paints and solvents, and there's been a lot of history in North America with magnesium oxychloride cement used as industrial flooring or in hospitals or other sort of industrial floors. One of the great benefits that I think is the antimicrobial nature. The ingredient magnesium chloride, salt, prevents mold. I've had pieces of the board, this is tested, and all these claims that I make have passed various ASTM tests, and we will share those tests with you. But I also do field tests at home. I left pieces of board out on my north-facing deck all winter. The deck is green, the boards are still white. No mold grew on it, and no mold actually grew on the boards that the Mago was in contact with. We have seen incidents of wood frame construction, site built, where the back of the gypsum is black because of the new energy code, wrapping the building tighter and encapsulated moisture in the framing. The gypsum paper is a petri dish for the growth of mold, and I think that is going to be a bigger issue coming up. The Mago board, or in the States Magnum, we've underdone, I don't know, now 35 tests or so. These are sort of the high points. The latest non-combustibility for Canada we did last fall, not on here. We just recently did STC testing at the Elwha Sound Labs in Washington State. Phenomenal building, a repurposed nuclear reactor built in the 70s that was never turned on. And now the only tenant is a guy that set up the world's quietest room next to the reactor chamber in this nuclear facility in Washington State. But we got an STC 55 with one layer of 15 mil board on a party wall. It's our goal to do the next couple of tests to have this board become the de facto party wall by doing a combustible fire assembly. We fully expect one 15 mil layer to get us at least 2 hours, maybe longer, based on other tests that are done, and we need to do a sealing test. The option that provides to us then is to provide a party wall that can be erected and fireproof by the framers during the construction of combustible multifamily buildings. We were involved with the first 6-story when I was prefabbing houses in Richmond that burnt to the ground. I was presenting to the Alberta building officials when a condo project burnt to the ground in Alberta last October, and a lot of us saw the pictures of the one in Ontario where the crane operator got rescued by helicopter from the pointy end of a crane as the condo project burns down behind them. This board can be applied by the framers using their standard tools, carbide saw, nail gun. It would add shear value to the interior walls. One side of a party wall gets done. The ceiling, we've now compartmentalized the building during construction, and once the building's locked up, that wall can be finished and become the finished wall surface. So that would be cost savings and time savings and limit the chance of these wildfires going through condominium projects. Sorry, yes?
So you're suggesting that the framers would put the gypsum, put the board on the inside. Who would do the insulation? Would you do the insulation and vapor retarder from the outside?
Well, for the outside wall, you might not put it on because that's an outside wall. But a party wall, if you do one side of the party wall, you can still access that for wiring and servicing. And then when the building is locked up, and that would still compartmentalize the building. But there's no need to do the outside wall really because it doesn't spread anywhere. So we haven't done one of those projects. We've talked to Len Garris, the fire marshal. We've talked to other people about it. Samir Adnani at CFT is our go-to code consultant for all things fire, and it seems like there's a lot of rationalization behind it, and I can't see any reason why it won't work. But obviously, the devil, as always, is in the details. When we first started to market this, we looked at it and we thought, my goodness, it does so many things, we're going to be scattered. We got to focus on something, and we originally focused on interior wallboard because it's ubiquitous. Every building in North America has a huge amount of it. Gypsum is not a great material. It works really well until anything happens to it. Insects, water, impact, and then it's a toxic waste. Gypsum and water, hydrogen sulfide, which is not nice stuff. So that's what we first went after. And I think when we are looking at applications that need high impact or resistance to water, and so New York has outlawed paper-faced gypsum if it's in a water-prone area. Richmond's considering it. They have a bylaw. Calgary did it. If you rebuild in the flood zone in Alberta, no paper-faced gypsum. New Orleans, the same thing. So now there's an alternative to paper-faced gypsum that would be resistant to any flood water or sprinkler water. And even if it does get wet, and I've had pieces now that I've run through my dishwasher 8 times and counting with no degradation, the board could actually be taken off and put back on if we want. So it gives a lot of extra abilities to make better buildings. Some of the other things, it does have a structural capacity. There are some tests that have been done. It is similar to OSB as far as its resistance to shear, but you guys are more the experts there. It's easier to finish to a level 5 because the surface is much smoother. It doesn't require plastering over the whole surface. And one board will do all of these jobs. It's not like gypsum where you have to pick between one of 8 different flavors. So that makes it more predictable that the right board will be used in the right place. The other secret to having your designs properly enacted on site is the ease of working with the material. Building houses in a factory, if a client wanted to use Hardie, WorkSafe required me to have fresh air respirators for the workers because of the silicosis. You need diamond saws. If you need special equipment or special methods to work with the product, then there's a chance that isn't going to be followed all the time. I think that's almost a certainty. This product seems to be extremely forgiving. It uses all the standard tools in a carpenter's or a drywaller's toolbox, and it's very forgiving to use and to finish in a number of different ways, whether you follow the suggestions we have or whether people put it up just like gypsum or as a replacement for Hardie. The expansion and contraction is much less, so even if they close fit the joints on an exterior paneling, we're not going to get the issues that you might with a cement fiberboard. This is a monolithic product, so it's not going to delaminate. So we don't care with the exterior cladding if the screws are countersunk or if the panels are closely fit. It worked with a variety of construction adhesives. and a variety of fasteners. Because of the magnesium chloride, the fastener should be coated, but almost any coating works. In fact, Grabber tested their phosphorus-coated drywall screws, which is a very mild, non-corrosive coating. They actually found that the magnesium enhances the protective nature of the phosphorus. Some of the other benefits are the simplicity that this brings. I sort of mentioned a bit that when you're a specifier designer, you've got to pick which sort of gypsum if it's inside. The guy estimating has got to price the right one, the guy's got to buy the right one, and then the guy on site's got to put the right board in the right place. Based on watching people work in my factory for 30 years, I can promise you that that doesn't happen all the time. Expansion and contraction is very low, either hygrometrically or thermally. I think the math is a 10-foot board in Edmonton, a delta of 70 or 80 Celsius, it's less than a 32nd of an inch. There's a job in Edmonton right now, they've got to take 900 sheets of CertainTeed off because they've all failed due to expansion contraction. So we don't seem to have that problem either. I've taken this board, it's a concrete board, so it'll absorb 27% by weight of water, and I've soaked the boards to that capacity, wrapped them in plastic, and then put them in the freezer, and nothing happens. I don't know where the expansion of the water goes, but the board doesn't change size, it doesn't change strength. When I take it out of the freezer, let it dry, it has the same characteristics it had before it went through that test. The ASTM test is 50 cycles of that sort of exposure. The outgassing, the impact, you saw the hockey puck. We've had hockey players actually shoot hockey pucks at it and give us comments about that. And the safety for workers. It does make dust. We absolutely don't recommend people breathing dust of any sort, but this is a health supplement. So the dust is a bad issue, but the material itself is non-toxic, which is a better issue. With the 12 mil board, our 1 hour certified fire assembly is a 12 mil board, 3.5 steel 12 mil board with rock wool or bad insulation. That's a W490 UL registered assembly. There are some other assemblies that have been done, but that's a work in progress for us, as I mentioned before, to get combustible assemblies and floor assemblies. If some of the shear can be moved to the inside, that's going to make our building stronger and give designers greater ability to, well, design more flexible and interesting buildings. The amount of time that contractors spend to put backing to attach grab bars or cabinets. If you have a 12 mil board and we put a screw just in the board, it can handle 200 pounds in shear, one screw. I've had an 8 mil board and put a hook in it, and from that hook suspended 9 gallons of water. I put it up in October on my deck and I took it down in March. And we went through enough windstorms that blew my picnic table over. And that connection is still there. The board is still as strong as it was. So its fastener holding ability is pretty strong. So as a replacement for, say, DensGlass, as an exterior sheathing, we can attach the cladding directly to it, which will simplify those assemblies. We're currently working with RCABC to get the material approved by them. We haven't yet had it in front of Suprema or SBS membranes to check for adhesion with that. I don't see any issue with it, but those are steps we still have to go through. But definitely to be in conjunction with roofing membranes or as an exterior sheathing for non-combustible construction, I think this is just better. And it's about the same price as a DensGlass as well, with less effort spent on the labor.